So, hello future engineers. I am Gian. Welcome to our online symposium, and I will be discussing our research titled Solar-Powered Red Tide Monitoring and Alert System using MATLAB Analysis via ThinkSpeak IoT Cloud and Arduino Mega Module, or also known as Red Alert, a red tide forecasting buoy, which is currently deployed at Bacoor Bay, Cavite. But first, here's a clip about red tide, how it affects our life, and our game-changing proposal. Let us now proceed.
Fish kill, skin irritation, respiratory symptoms, and paralytic shellfish poisoning. These are the effects of red tide, otherwise known as harmful algal blooms affected coastal areas. Eating red tide contaminated shellfish can cause paralytic shellfish poisoning to humans. There is no antidote and direct treatment for paralytic shellfish poisoning and is considered as the most common shellfish poisoning syndrome.
Nangatok ang mga barangay officials sa Bonbonan, Siato, Negros Oriental para pagbawalan ang mga residente na manguha ng shellfish sa Tambogo Bay matapos magpositibo ito sa red tide toxin. Itinaas kasi ng Bureau of Fisheries and Aquatic Resources o BFAR ang red tide alert sa 7 lugar na nagpositibo sa paralytic shellfish poison.
The Conservation and Environmental Protection section under the Fisheries Resources Management Division of Bureau of Fisheries and Aquatic Resources in Quezon City uses YSI Professional Plus multiparameter instrument. However, the YSI multiparameter instrument has faced certain issues. Boat riding and sea current affects the accuracy of water parameters. Water sample analysis takes days to yield the result. YSI multi-parameter instrument set cost 65,000 pesos excluding the maintenance cost. Smart Red Alert. The Smart Red Alert system uses a combination of temperature, salinity, and dissolved oxygen sensors to predict the cell density concentration of the algal bloom on the sea surface. A machine learning integrated with the sensors processes the acquired data every 5 seconds, which can be viewed in a smartphone application. A triggering value is set on the cloud server, which activates the notification system. Automatically sends a notification through the nearest BFAR facility.
For the continuation, I will further discuss the summation of the research prototype. Let's start first with the methodology. The general framework shows the software development of the study. The system is monitored and controlled by the ThinkSpeak IoT Cloud, which sends analyzed data through the ThinkView mobile application. The if this then that or IFTTT platform triggers the cloud system when a specific sensor value reaches an alert level at which a notification will be sent through the application. The cloud also displays regression model formulated by the MATLAB analysis application. The design of the anchored buoy was based on the specifications of NextSense CV450 data buoy and was altered to be cost efficient. The photovoltaic system consists of solar panel module, 45 watts in total, 5 ampere-hour sealed lead acid battery, and a 30 amps charge controller. The buoy prototype was deployed in a shellfish and oyster farm in Bacoor Bay, Cavite. A non-disclosure and option agreement was signed between the Binakayan Shellfish Demonstration Center and the university to properly monitor the activity of the device. Second, the results and discussion. The regression learner application displays the best trained model of the given dataset. A five-fold cross-validation is fitted for 99 observations. The model is exported through the ThinkSpeak cloud server. The cloud server collects both the trained model and actual sensor data to generate a prediction graph of red tide occurrence. This process is determined through the MATLAB analysis application. A notification alert system will be sent to a smartphone whenever a triggering value is reached by the prediction model indicating the possibility of red tide. Lastly, the conclusion of the research prototype. The program that determines the predictability of red tide using regression machine learning was successfully achieved using MATLAB. Based on the RMSE of the trained model, it yielded a result of 2.934. The lower the RMSE, the better the dataset. The project was successfully implemented and done. However, the proponents would like to make the following recommendations to further improve the project. Number 1. Additional water samples to be processed and correlate the features that will be added in the dataset for improving the accuracy. Number 2. To have an interconnected red tide buoy system throughout the country to help the fishermen and townsfolk know whenever a red tide will occur. For the references, here are the following.
And that's it. We hope that you have learned a lot through this research prototype. I would like to thank my research members, Jerome, Kathleen, Genevieve, Migs, and our research advisor, Engineer Cherry G. Pasion and Engineer Nilo M. Arago for guiding us through our journey. We would also like to thank the Bureau of Fisheries and Aquatic Resources, National Fisheries Research and Development Institute, and Binakayan Shellfish Demonstration Center for sharing their knowledge and resources to make this project possible. And above all, God for His unconditional love and grace. Once again, I am Gian. Thank you and good luck, future engineers.